Hello, everyone. Apologies for the technical difficulty. Stephen is now sharing from his side. It's not working from my end. So this is Ali Riva here. I'm joined with my colleague Stephen Bratro. Stephen, maybe you can start with a quick intro.
Hi there. Yeah. Hi, everybody. I'm a developer at CRAF'd GmbH in Germany, and I helped to develop the Matus platform that you'll see in this presentation.
Thank you very much, Stephen. So this is Ali Riva here. I am the founder of Kiangle AI in Portugal. I study the impact of AI on our societies, economies, and personal lives. My work combines philosophy and anthropology to trying to dissect the impact of AI on businesses and also the ethical implications of AI. I also work on digital dexterity and trying to draw parallels between AI and our ancestors' technology leaps, studying the human experience with technology since the Stone Age and understanding the phenomenological experiences with technology as well. Next slide. The next one. So what you are seeing here is a causal loop diagram by the U.S. Army staff focused on the Afghan conflict. And as you can see, it's really complicated. General McChrystal remarked that when we understand that slide, we'll have won the war. And he speaks about the complexity of conflict. And some have even dubbed that it is the worst PowerPoint slide. Stephen, I think the slides are not showing anymore. Can you still see the slide?
My screen sharing ended unexpectedly. I'll try and get that back again. 1 second.
Sure. So this diagram is not just about the Afghan conflict. It's a metaphor for organizational conflict. As the general pointed out, reducing the war to rigid bullet points fails to capture the interconnected political and the economic and the ethnic forces at play. And in this presentation, we are introducing to you Metis, which is a multi-risk AI-based scenario planning platform. And we do believe and we recognize that war, like organization conflict, is not static. It's a dynamic process. It's non-linear. It's really far from equilibrium, and it's really influenced by initial conditions. And we are represented by a complex system similar to what you are seeing in this causal loop, where countless agents act based on local conditions, leading to a global impact that can shift the environment of all other agents. So this is the essence of interactive complexity, where the system components intersect in unexpected ways. So giving rise to emergent properties that might defy prediction. And as we delve today into Metis and its applications for anticipatory action, I believe that it's crucial for us to navigate such complexity and rethink the way we build strategies for anticipatory action. Next slide. So Metis is a dynamic and open platform focused on scenario planning and analysis. So on the left side, you can observe what we call the smart cockpits. This is the front end of Metis. You can think about it as an intuitive interface that decision makers will interact with. So it's user-centric and can guide you through a multi-risk environment. And to the right, this is our backend. This is where we fit in our methodology and our models, which of course I'll dig deeper into in the next slide. And it's a card-based approach where our models are interconnected from a system thinking perspective. And one thing to add is that Metis is adaptable. So it can adapt to any model and it's open to any data sets that can be provided by the organization. Next slide. So yes, keep on clicking, please. So as we delve deeper into the topic, let's recognize that as I said, conflict is not linear; it's multi-layered system. So starting with linear models, these models are straightforward. So they paint a direct path from A to Z. While they are simple and easy to understand, they are heavily they rely on causality. But here's the catch: real-world conflicts often defy this basic cause and effect reasoning. So if we say that X troops are added, it will not mean that Y outcome will occur. So as we move to a broader perspective with scenario planning and with the range of outcomes or range of futures, this approach imagines multiple potential outcomes. So it's like military scenario planning, but it's broader in scope than linear models, but at the same time, it misses the details of how each scenario might unfold. Next, this is where we can build like branching scenarios with storytelling. So this is where I could say things get interesting. Through narrative techniques, we start to factor the cultural, the psychological, the socio-political elements. And if you ever seen like the war gaming scenarios, they are prime example for this. So, however, for them to truly be effective, they need to evolve alongside the dynamic environment they represent. This takes us to the next one, which is the interconnected system, our fourth stage. Here we acknowledge as I said, the web of relationships, the web of connections and conflicts. So it's about understanding the ripples in the water, how one change can cascade effects throughout the whole system. So for those who have looked at interventions in conflict zone, this systemic thinking is really crucial. And if we move to the final one, which is the complex system with situational awareness, so this represents the pinnacle of our understanding. So it engages the unpredictability, the chaos that are present in conflict. And this is where we are talking about the real-time data-driven models that are constantly adapting to what's happening on the ground. And the closing note for this slide is, if we map these systems on an uncertainty spectrum, linear models would be at the low uncertainty, and as we move to the complex system, we are heading to the high uncertainty. And in the graph or in the causal loop that you see now, this offers a qualitative overview of system structure. So if you have seen causal loop, like the one in the first slide, but the one in this slide, this is just a subset, this system dynamics model that we built for, and a quantitative, not only qualitative model for the Syrian conflict, and not all the Syrian conflict, only the northern Syria side. So you can imagine the complexity that we are dealing with when it comes to conflict. Next slide. Next. Yes. So next slide. So speaking about the framework, our Metis system framework, at the highest pinnacle, you can see the strategic layer. This is characterized by high abstraction. This is where we house what we call the Metis board, which is driven primarily by system dynamics. This is the central hub, if you can say, for the global conflicts and the humanitarian challenges that we might face. Going to the middle tier or the tactical tier, this is where we build situation rooms, where we have different type of modeling, not only system dynamics, mostly discrete event modeling. And in the expert cockpits at the foundational level, this is where we utilize agent-based modeling, where we dive deep into the granular details and to ensure that the resources are effectively allocated and immediate needs are met at real time. Next slide. And just to note that, as I said earlier, that we are open to any model. So it's not only about these three models. And I will take you one by one to understand what we are trying to simulate. This is just an example of an expert cockpit in northern Syria. So this card will be the starting point for users. So this is the main card where users would like select the scenario that they want to analyze. They could select from a list of predefined scenarios, or it could be generated scenarios. So user would narrow down to the most likely scenario, and these scenarios are ranked by likelihood. And scenario generation is a well-known method in foresight and studies. So however, creating scenarios can be time-consuming, and integrating a diverse range of initial information like reports or expert interviews can be challenging. So we are trying to automate that. And one of our main tasks in scenario development is to understand these influences. And we are using like Monte Carlo methods here and web and text mining in order to aggregate, to do this aggregation and build or generate these scenarios. So the main goal for this is to allow users to select or define between different scenarios based on real world events and expert opinion. And we utilize machine learning algorithms to auto-generate these scenarios, as I said. Next. So now the next step is to really track the indicator. This feature would allow users to explore the what-if scenarios, so they can adjust the indicators and see how this adjustment could affect the outcome. So it would provide a hands-on, like interactive experience to understand the relationship between the indicators and the potential impact on conflict risk. Next. So here we monitor these indicators and to monitor key indicators that provide a quantifiable measure of factors, which is very important for us in the decision-making process. And as I said, we gather data from multiple sources like satellite images, social media, and on-the-ground reports. Next. It's very important where this is where we identify triggers. So the expert cockpit could include alerts or notifications that are triggered based on certain when certain thresholds are reached. So let's say if average mood among the Arab population falls below 3, or if the Arab mobilization rate surpasses 60%. So depending on the ethnicities that we are trying to model here. Next. This is the scenario evolution card. So this is where this card shows how the scenario is evolving over time. So it shows the like a heat map of the region, highlighting the areas with high tension or conflict risk, and provides a dynamic view of the evolution and aiding in resource planning. Next. And we believe that we need to make our systems human-centric. So this is where we are using LLMs, using GPT to create engaging narratives for the agents that we are simulating. So with agent story generation, we are blending the mathematical models of the real life stories of conflict agents. So trying to immerse deeply in the experiences of these individuals in conflict zone, trying to build empathy with the agents that we are trying to model. Next. And in here, this is the risk prediction card. This is where we focus on the future state of individual indicators and how they might contribute to conflict risks. And this is where we allow users like to compare the predicted future conflict risk under different indicators like the mood, the unemployment, the population, and so on and so forth. Next. Since we don't have much time left, yes, next, please. Next. Next. For situation rules, these are custom developed with the organization. And situational rooms are, as I said, on the medium abstraction level or on the tactical level. And I would give you just quick examples of what can be developed in situation rooms. So, for example, things like the composite conflict risk scorecard. So this is where we integrate multiple conflict indicators such as ethnic tension, economic metrics, the spread of misinformation into a single score. And we can also have a line graph, we can show a line graph, for example, to trace the evolution of the conflict risk score over time. And we can also overlay and compare multiple scenarios. So whether you are looking at scenarios A and B or A and C, we can envision these sub-scenarios and assess the impact. And emergence and feedback loops are very important in complex systems. So behaviors at small scale can lead to unexpected patterns. So this is something that we also include in the tactical card. And we also do sensitivity analysis here, where we showcase the model responsiveness to changes in various parameters. So you can identify which factors, like the rate of economic growth or government initiatives, influence our model prediction. And we can also showcase an anticipatory action card. This is where you can test policies and impact of policies. So imagine you are considering an intervention to reduce ethnic tension. This card would allow you to simulate its effects by adjusting, like for example, a slider. You can observe the forecasted changes in real time and see how these interventions can influence the broader system. Next, so the real essence here is to really think about it as a system, from a system thinking perspective, where everything is interconnected. Next, so the next please. So the METIS strategic board. This is where we provide the comprehensive, the high level overview for humanitarian efforts, and this is where we consolidate the key information for specialized monitoring system and situation rooms for decision makers. And just to summarize things, the main goal is to take a human-centric approach, as I mentioned, through the agent story generation, our ability to capture time delays for the prolonged consequences of our interventions, and also the ability to have dynamic scenario planning and to test policies and to test impact, which is I believe very important here. And our platform can predict not just we are not talking about our goal is not just to predict the conflict, but also the secondary impacts like food insecurity, or to simulate people who will be displaced. So in our agent-based modeling, we can simulate how refugees would move from one place to another. Next slide. So this is in a nutshell. I think we surpassed our time. Thank you very much, and I leave it now to questions and yes.
I believe we have 2 questions in the chat.
Yes, so I think thanks, Gregor. I think this is a very important question regarding the evaluation of the model output. This is where we use sensitivity analysis and sample forecasting to measure the model outputs and make sure that we can increase the accuracy with time. How do you? Another question: how do you sensitize the different output scenarios monitoring models? Can you explain this question in detail? You mean, if you can just elaborate this question, please. Rob, so I want to tell you that our platform is still in its initial stages. So we have worked on this with one global NGO, but we didn't yet put it into real world practice. But we tested our results, and for example, we built like the demo that you have seen for Syria, for northern Syria and Deir. We modeled this before the events that happened in Deir and the I think last month or 2 months back. So, and we were seeing that the mood was declining, and we were able to predict that there's something happening there. So this was one of our, let's say, example where we are able to compare the results on the ground. Yes, Emma. This is a good question. So this is something that I was trying to emphasize in the presentation, which is analyzing the impact of specific policy inputs. Since we are using, like, if you see in our methodology, we are moving from the let's say agent-based models to like the very tactical or the micro layer to the strategic layer. And the strategic layer, this is where we analyze all the interdependencies. And this is where we can find the nitty-gritty small impacts that might, or small events that might impact the whole system, or small, or any interventions or on any action that might be taken that would affect the whole system, since we are not building this as a silo system. So it's all interconnected, and it's as I said, it's even an open platform. So it's open to any model that we might use. So we are using open tools like Python for developing all this, and Stephen might of course dig deeper into these technical details. But this is something that of course you can do in the system. Regards to having this as open source, we still don't we still didn't take the decision with regards to that. But for now, it's an open platform, not open source, but it's open, so it can connect with any of the data sets in your organization or any API. Stephen, maybe you can jump in and discuss
Yeah, of
this
course.
in more detail.
So yeah, I'd say a key feature of the Matis platform is that it is to a certain extent an aggregating platform. You know, you can connect it to any external API or source or data set, or even integrate any existing data products or software that your organization might use. I don't know, Amazon QuickSight, for example, or Power BI from Azure, or any other kind of analytics tool. Anything can be integrated and is entirely flexible. I guess maybe to give a bit of background on what enables that flexibility, under the hood of the Matis platform are Python Jupyter notebooks, which are a kind of standard tool in data science and machine learning. But these notebooks are interconnected with inputs and outputs, enabling you to build up complex predictive systems like the one we've seen today, the model with the theoretical background from Ali. So
yeah, thank you, Stephen. Gregor, so if I understood correctly, analytical outputs are presented in Matis board. How do you synthesize the underlying analytical outputs from the different approaches models? If we go back, Gregor, to our methodology, and I would tell you that if we take both the simulation community and the AI community, they are now disconnected. So there are numerous tools that you can find online focused only on agent-based or only on system dynamics or on all of them, but they are really, it's really hard or complicated to integrate them with machine learning models. So what one of our uniqueness here is we are bringing these two disciplines together, the simulation models with machine learning models. And the way we structured it is through this pyramid that I've showcased to you, which is in the very top, we are talking here about focusing more on system dynamics, because system dynamics is mostly suited to analyze interdependencies, and this is where decision makers might be interested in things like policy interventions and impact of policies. So they might not be interested in the micro details. But once we are talking about in the micro details, this is where we introduce agent-based models, where we can model, and we have built this model also in the system where we can model the movement of refugees from one place to another. So it depends on the layer, it depends on the audience or the user that we have. This is how we approach it through this methodology. I hope that I was able to tackle your question. Yeah, I believe including simulation is very promising, and I would refer to OCHA paper. It was published, I think, 4 or 5 months back, and they're saying that forecasting is not enough, and we need to, like, it's very complicated to really tell whether we will have or will not have conflicts. So it's better to work on probabilities. And they mentioned that we might need to do research or to work on simulation. And I believe I have read that they mentioned also agent-based modeling. And I believe in that as well. In times of uncertainty, and that's why I showed the graph of moving from low to high uncertainty. We all believe, and even in the first panel in this conference, this was discussed, that we are living in very uncertain times now. And it's really complicated to just rely on the data, the historical data that we have. So forecasting alone, I don't believe might be enough in these uncertain times. That's why simulation, and not only simulation as a domain, but the way we can blend it with AI could be promising in the study of conflict. I believe. Any more questions? Thank you everyone for joining us today, and feel free to reach us. And thank you, Branka, and thanks for the organizer of this interesting conference. And thank you, Stephen.
Yes, thank you, everyone.